Welcome to another episode where we delve into geodesy and distinguished geodesists in the world. My name is Mehdi Ishaq, and today we have the privilege of sitting down with Professor Harald Schuh from Technical University of Berlin. Professor Schuh has made significant contributions to space geodesy, earth rotation, ionosphere, and troposphere modeling. Please join us as we delve into his career, insight, and how his research has affected our knowledge in the field. Thank you very much, Professor Shu, that you accepted my invitation. So, please tell us about your journey in geodesy and what was the key motivation which kept you active and interested in the subject during years.
Yeah, thank you very much for this invitation to give some of my experiences. In fact, at high school, I was very much interested in mathematics and physics. And then in the 70s, there was a new topic coming up, computer science, informatics, which also caused my interest. And finally, I decided to study geodesy because of the relation to the Earth. And because I wanted to do something connected to the Earth, maybe also in favor or supporting investigation of the Earth. And if you ask me today about geodesy, I would say it's based on these four pillars: mathematics, physics, computer science, and earth sciences. And if you combine these four pillars, you arrive at geodesy. And I never regret it. Always has been interesting, very fascinating. Had a lot of interesting applications, which in fact I even didn't know when I when I selected the topic. But the special application is, for instance, dealing with the orientation of the Earth, Earth rotation, changes of Earth rotation, also the main product, which are the reference frames, which are relevant to a lot of other studies, which are kind of basic requirement for monitoring a lot of other effects like sea level rise or plate tectonics.
Thank you very much. Can you tell us what has happened that you, when you started geodesy at university and up to you became professor for this in this journey for a long time? What happened?
Yeah, there have been a lot of changes, continuous change in the last more than 40 years. And when I started, for instance, there was almost no satellite that could be used for geodesy. There was no satellite geodesy, just a few of basic concepts. There were two or three satellites that could be tracked by laser. There was no GPS, no GNSS. There was no Doris. There was a kind of predecessor of Doris, also using the Doppler effect, but that was all. And then there was VLBI was brand new. In Germany, we had two or three professors who went to the United States, and when they came back, they reported about a new technology, space geodetic technology called VLBI, that has been developed by astronomers to be used for astrophysics. And then people, very soon, they realized the whole story can be inverted, and we can also determine the distances between each two radio telescopes with a very high precision. We can determine reference frames on the Earth and also in space, and the relation between these reference frames, which are the Earth orientation parameters. And so all was brand new in the 70s, 80s, and in the last 40 years, it has developed so fast. Maybe later I can give some more examples on that.
Nice story. What have you seen as main challenge or challenges that you have observed during these years?
Yeah, challenges. There have been a lot of, let's say, scientific challenges, improve our performance, increase the measurement precision and the accuracy of our results, improve the spatial and temporal resolution. These challenges, let's say, were nice, and that was our daily work to work on these challenges. There were also challenges on the management side and management operational side, which were causing more headache. For instance, I give you one example. We were in charge of the Grace Follow-On mission, which is a bilateral mission between Germany and United States. In United States, it's the NASA. In Germany, it was the GFZ, the German Research Centre for Geosciences, where I was the director of the Geodesy department. And there came a challenge around 2015, 2016, because we were in charge of the launch. And originally, the launch was planned from a launch site in Russia, done by a Ukrainian-Russian consortium. This was before the conflict. And then all these problems started in 2016, and it was clear in 2017 we had to find another launch site, another company doing the launch. Finally, we decided to do the launch from California with the Falcon 9 rocket of SpaceX company. But before this transition, we had a lot of teleconferences, a lot of discussions from both sides of the Atlantic and with international partners. So this was a challenge which really caused a lot of problems, a lot of headache also, and finally it could be solved.
Wow, very interesting. Wow. But Professor, you have, during these years that you have done a lot of researches and worked on different subjects. Which one of them you really like it and you from your heart, you would like most for comparing to the rest that you have done?
Indeed, I always tried to switch to another subject. I think you cannot work 40 years on the same subject in your life or 45 years. So I tried to investigate various effects that can be observed by space geodesy, by space geodetic techniques, like plate tectonics, causing earthquakes very often, like Earth orientation, which has a lot of causes that trigger these different periods, different variations in Earth rotation. We can also apply space geodesy to investigate the atmosphere, in particular the lowest part, the so-called troposphere, up to 10 kilometers in terms of humidity above the stations, and also the ionosphere, which has a lot of important applications. And if you observe using two frequencies, we can determine ionospheric models from GNSS and also from VLBI, also from DORIS. And so it's important, I think, sometimes to change the topic and to get new ideas and new findings.
You like all subjects. That's what I think. You are all choice subjects. So interesting. But Professor, still, when I go to the society, so when I talk to people, they ask me, well, what is your profession? What have you studied? I say geodesy. They ask, oh, geophysics. No, geodesy. Oh, geology. No, it's I have to explain a lot so that they understand what we are doing actually, what is geodesy. So, and on this, what can we do that society understand geodesy better?
Yeah, that's an ongoing problem indeed, that geodesy is not so well known to most of the people. Sometimes it's a hidden champion because it's needed for a lot of applications of the population of our society. There have been some studies that found out that 80% of our daily activities need some basis from geodesy, produced by geodesy, in terms of reference frames, in terms of Earth orientation, satellite orbits, and it's an ongoing problem. We have to work on it using all kind of PR methods for public relation, inviting people to Day of Open Door, to special events, giving presentations to a general audience, for instance, writing articles in the newspapers, be present in social media nowadays is also very important. So we really have to spend part of our time, part of our working hours to do PR activities and to inform the people about importance of geodesy. Educating decision makers, politicians, is even more important than just informing the general public, because decision makers, they will decide about future investments, future priorities, and there we definitely should continue to write white papers about importance of geodetic infrastructure, of geodetic work, and bring it to the politicians, to the ministries. In Germany, we have the Ministry of Internal Affairs, Ministry of Transportation and Traffic, and also Ministry of Education and Research that are relevant for geodesy, or opposite, geodesy is relevant for these ministries. And there we can always refer to a resolution on the GGRF, Global Geodetic Reference Frame, that has been approved by United Nations General Assembly in 2015 about the importance of geodetic reference frames. It was approved by all 193 member states of United Nations under UN GGIM, United Nations Global Geospatial Information Management. And this allows us always to refer to this resolution about the importance of our work, of our goals, of our targets.
That's really important, yes, because I see that lack of understanding of politicians can affect, actually influence the subject and people very much, actually.
Yeah.
I
And
have seen that, yes.
yes. And they understand if you try to explain it to them. They understand if you try to explain we need it for navigation, for finding our way, and then a navigation system in your car of your driver. He has used the navigation system which is using GPS, and we determine the orbits of GPS, and a lot of applications. In Germany, geodetic infrastructure now is considered as so-called critical infrastructure, which deserves special attention by the politicians and by the government. So critical infrastructure, also with respect to defense issues. And so fortunately, now we got the label as critical infrastructure that has a high priority and high relevance.
I really agree with you. This is the challenge, a really big challenge that we always have. But yeah, I do agree. We have to be more active, and it is our responsibility to show it.
Geodesy has developed, became much broader. Nowadays, there are topics called seismogeodesy, volcano geodesy, cryospheric geodesy, atmospheric geodesy, hydrological geodesy. So for a lot of our neighboring disciplines, we need geodesy, but we have to educate, we have to teach our neighbors that it's not just a black box. What we do is important science, because we have to develop the scientific basis, we have to develop the technologies that are applied, and we have to understand, we have to apply new concepts and the methodologies. And that's really essential. That is not just used as a black box.
Thank you very much. But Professor, what is your advice to younger generation or younger geodesists around my age or younger than me?
Yeah. General advice, I would say be flexible. Be flexible when using your brain, using your mind, use your scientific fantasy to develop and apply new concepts, new technologies for innovations. There's always still a lot of space for innovations. And so don't do the same thing for 40 years. Try to develop new concepts. That's what I would recommend. Also, be flexible in terms of moving to different places nowadays in science, research and science. Usually, you cannot stay in the same city, the same institute for your all your professional life. I moved several times in my life, and it was always a good decision to move to another place and to join a new institute. And that's what I would recommend. Be flexible.
That's really correct. With being at different places, we can learn new things from different persons. So, being
Absolutely. Yeah. I always tried to develop new ideas, to trigger innovations with new ideas, new scientific concepts, new scientific ideas. And I had the pleasure to work together with very talented PhD students and also very good postdoc scientists. Um, I, uh, in my career, in total, I supervised and co-supervised almost 90 PhD students. And for about half of them, I was the main supervisor from more than 20 countries, and almost 20 of them are already on a position as a professor, assistant professor, associate professor, or even full professor. That means they already started to educate the next generation of students, of scientists. This makes me somehow glad and thinking positive about the future.
it's really wonderful, incredible, incredible. You have done a lot. I am really appreciative to hear this. I really appreciate it. Thank you very much. How do you see the trend in the, for example, in the future for 10 years, 20 years?
Yeah, that's also very promising. I think we are uh, for a promising future. There have been new technologies which are upcoming in the last 5 to 10 years. For instance, using quantum technologies. There are quantum gravimeters that you can even buy on the market, quantum accelerometers. There are new clocks, optical clocks with a very high precision stability, 10 to the minus 18, 10 to the minus 19, that will allow to determine height differences just from reading the clock or the differences of two clocks. And so that's one very exciting development. Then we have new satellites, new satellite missions. For sure, there will be follow-on missions of Grace follow-on, and there is also a new mission that I would like to mention called Genesis. Genesis is an ESA mission that will be launched around 2028. And for the first time, it will allow to connect all four space geodetic techniques on one satellite to do collocation in space. That means GNSS, satellite laser ranging, DORIS, and VLBI with a VLBI transmitter on the satellite. So this will definitely stabilize and improve the reference frames. And then we have also a lot of new LEO satellites that are getting launched every day. As you know, there are fleets of satellites, new constellations that are launched that can also be used for navigation positioning on the Earth. And finally, what I should also mention here is computer power. There are still ongoing improvements of computer, developing very powerful computers, computer clusters, and this goes along with AI. Nowadays, artificial intelligence is a very hot topic, and the last 2 to 3 years, all of our projects that got approved have a component of application of AI, which will allow to do a lot of more studies, pattern recognition, investigating very big amount of data, and so AI offers a lot of new opportunities. So a lot of new developments that are relevant to geodesy.
So, Professor, thank you very much for your valuable time that you spent with me, and I'm
So
sure that audiences will enjoy listening to you and your vision about geodesy.
yeah, thank you also to you for this activity. It's